All right, we're gonna go over the structures of the ear right now. Starting with the external ear. The external ear runs from here to the tympanic membrane. We have the auricle or the pinna. We have the external acoustic meatus, which is the tunnel leading into the tympanic membrane. We have the tympanic membrane, which is your eardrum. On the internal side of the tympanic membrane, we have the middle ear, which is this region in general. It houses the auditory tube, which runs down into the oral cavity. It has the tympanic cavity, which would just be this general space in here. It also has the three ossicles, the three smallest bones of the body. The malleus is the one with the rounded head like a mallet. The incus is the middle one, and it has the pointy part. Then the stapes is the most medial, and it connects the ossicles to the internal ear. These, when the tympanic membrane vibrates, the ossicles vibrate, and then those vibrations are transferred to the inner ear. So once again, here's the stapes. The stapes covers up the round window. It vibrates against, or oval window, sorry. It vibrates against the oval window, which transmits the vibrations into the cochlea. Then those vibrations make their way back out via the round window. So oval window, round window. The round window, so it's 28, the circle right here. You can see if we put this back in, that would line up right there with that 28. So technically the round window is shown two different places on this model.
That's pretty cool.
Moving into the inner ear, we have the cochlea, the vestibule, and the semicircular canals. Each one has its own specific function. Cochlea is for hearing. Vestibule is for linear actions such as up and down, forwards and backwards. And the semicircular canals are for rotational movement. We're going to start with the cochlea, the one that looks like a snail shell. So the cochlea has three distinct ducts. And we're going to do a little visual here. Starting out, so we start out with this bony tube, and within that we add in a membranous tube, which gives us three ducts. 1, 2, 3. The top one is the scala vestibula. The middle one is the scala media. The bottom one is the scala tympani. And then lastly, the basal surface of the scala media has a membrane here with the auditory hairs that sense hair and sound. And that membrane is called the spiral organ. So taking what we learned here and applying it to the model, as we go up the snail shell, starting here, we have a top scala, a middle, and a bottom. The top one, the orange, is the scala vestibula. The middle one, the white one, is the scala media, and that's where on the basal floor we would have that spiral organ. And then the bottom one, the blue, is the scala tympani, and that pattern circles up as the cochlea coils. We have the vestibular cochlear nerve right there. Moving into the vestibule, remember we said this is for linear actions. Within this vestibule, we can't see it on the model, but within it we have a utricle and a saccule. Each of those have their own macula. All right, can't see it, just know that they're there. Know that the utricle is for forwards and back motion, while the saccule is for up and down motion, and that's it for the vestibule. Over at the semicircular canals, we have, that's rotational movement, and the bases, right where they connect to the vestibule, each one of those houses a crista ampularis and a cupula. So the crista ampularis is the raised part here that houses the hairs to sense rotation, and then the cupula is the gel on top. So as your head rotates and moves, this gel is going to tip, which tugs on the hairs, and that sends signals to the brain to say that rotation is happening. So simply for this lab, remember that the crista ampularis is the structure that houses the hairs, and the cupula is the gel cap on top. And that's it for the structures of the ear.